What's poppin', dogs? Mr. Allen here talking equivalent functions in this video. So we got to determine which of the following functions are equivalent to f of x equals x squared minus 5x plus 4. There could be multiple answers here. I got 4 equations and a graph, so 5 to choose from. Let's start with g of x. How am I going to figure this out? Well, I think the easiest way, or the most straightforward way, is to put things into standard form. Because at first glance, you're like, well, if this was in factored form, it'd be x minus 4, x minus 1. That's clearly not this one right here. But there's that plus 10. How is that going to affect it? So let's multiply these two together, giving me x squared, that's the first part here. Then x times 1 is just x. Negative 6 times x is negative 6x. Negative 6 times 1 is negative 6. And then plus 10. And then we got to combine our like terms. Now, some of you might be able to do this one on the fly and combine it. Totally up to you. I like to show all my steps here so that you guys don't, miss anything. So now I got x squared minus 5x. And then negative 6 plus 10 is positive 4. Oh my goodness, they are the same. So yes, g of x is going to be equivalent, and that work shows it justifies it, right? How about h of x? Well, I did just say that if we were to factor x squared minus 5x plus 4, we would get x minus 4, x minus 1. So this is clearly not going to be one of my solutions here. And you could maybe put this next to the problem or say like, hey, this is the factored form. You could also FOIL this one out and put it into standard form. But I think that one right there, pretty straightforward. Plus, I feel like this factored form is going to be super helpful looking ahead to k of x right now. Yeah? If I factor my f of x and I set each one of those factors, let me put an equal sign here. If I set each one of those factors equal to 0, so x minus 4 equals 0, and x minus 1 equals 0, I'll get x equals 4 and x equals positive 1. Are those my two x-intercepts? Absolutely. And is this right here, if I put 0 in, is that my y-intercept, which is exactly what I have up here? So we could say x-intercepts are 4, 0 and 1, 0. Y-intercept is 0, 4. That checks out here. So we're going to say yes for k of x. I should not have picked blue. It's a different shade of blue. But there we go. So k of x works. G of x works. H of x is out of it. All right. So you want to have it like at least with a graph, probably 3 valid points. You could even do your axis of symmetry here, opposite of b over 2a. So that'd be negative 5 over 2. That's 2.5. So x equals 2.5. That seems logical. You can plug back in to get your vertex, but really, I think the two x-intercepts and the y-intercept and it being positive, opening up, those are all enough to justify it, okay? Now, if it's a multiple choice, you're just selecting and you don't necessarily think of a full, justification there or explanation as to why they are equivalent. It's enough to say, like, if you're comfortable saying, yes, this is it, or do you want to do a little more to make absolute sure, okay? Next one here, I'll go with orange on this. Keep the fun colors moving here. That's vertex form, right? So this would be 2, negative 3. And pretty clear that this is not going to be it because we got like 2.5, maybe a little bit below negative 2. So not going to be it. But let's just say, because we know that this is the same as that one, right? But let's say I just had these two functions. I didn't have the graphical representation. Again, I think it's probably most straightforward to put this into standard form. So let's do that. So I've got x minus 2 times x minus 2. Minus 3. But if I was on a test right now and I've already verified this, I'm saying no to this one. And then moving on, come back and check if I've got the time later, because time is of the essence when it comes to test taking. All right, now I got to multiply this out. So we got x squared. We have negative 2x and negative 2x. That's negative 4x. I am going to skip that step I talked about up there. See if you guys can handle that. And now I have x squared minus 4x plus 1. Okay, so nope. M of x is not going to be our answer there. But what about n of x? It's like a not quite vertex form, kind of like a weird, right? We have that kind of binomial, it's squared vertex form thing, and we have the plus 3, but this minus 7x throws it all off. But who knows? Let's see what happens. See what it looks like, okay? Let's multiply it out just like we did here. I have x plus 1 times x plus 1. Common mistake here, guys, is 2. Just think you can distribute in your exponent. Can't do that with a binomial. You can only do that if it's just multiplication inside the parentheses, okay? Next up, we're going to multiply. We got x squared. We got 1x and 1x. That's 2x. 1 times 1 is 1, minus 7x plus 3. We have, combined like terms, drum roll please. I got minus 5x, right? These go together, minus 5x. And then 1 and 3, that's plus 4. So I did like the underline and the double underline. When I got a lot of like terms that I got to do, I'm going to try to stay organized like that. And oh my goodness, it is. So yes, this checks out. They are equivalent. There we go, guys. So again, the most straightforward, most time-consuming, but guarantees you're going to get the right answer as long as you didn't make a mistake, is putting everything into standard form, okay? You can go from, like if this was in factored form, you could put one of these into standard and then go back to factored or something like that. But I feel like it's just the easiest comparison is putting it into standard form and seeing if they're the same. There we go. All right, guys, if you have any questions, pop it in the comments. Otherwise, thank you for watching and have a dope day.